Good morning, listeners, and welcome to today's class. Today, we are still continuing to make efforts in bringing to bear to our listeners the relationship or the links that exist between logarithms and indices. In one of our previous classes, we already had showed efforts in making our listeners to see the connections that exist between logarithms and their indices by lifting up some questions and providing solutions with them. Today, equally on the course to deepen our knowledge all the more in the links between the relationship or the links between these two concepts. We have called up some questions to equally solve with you, at the end of which I assure you, your understanding between these links must have deepened very much well. So stay with us as we call up these questions and solve with you. Question number one says, and I write. Question number one says, and I write. This is question number one. That number one says, what is the value of log base 7, log base 7 of root of 7 of root of 7 of root of 7. That is the question that they ask us to evaluate. We are required to find a value that is the same as log base 7, log base 7, general square root of 7, inside it square root of 7, and inside it square root of 7. We are to find the value of this. We are going to go about this step by step in order to make sure that at the end of solving it, you have every idea on how to go about this. So as a word of solution, I write solution. First of all, we want to let you know that this which we have this place is the same thing as log of 7, log in base 7, general square root of 7, square root of 7, square root of 7. Is the same thing as, this is the same thing as log in this base 7, log in this base 7, general square root of 7, which is what you have here, multiply by, this is another square root of 7, this is another square root, the same multiply by root 7. This and this are the same thing in mathematics. That is step number 1. Step number 2 is that this quantity is equals. Remember that any day you talk about root 7, it is the same thing as 7 raised to power 1 over what? 2. That is what it means. And this 7 that is here contains only 1 square root. So it is going to be raised to power what? 1 over 2. So meaning that this is the same thing as log in base 7, log in base 7, I'll come to this very 7, the first one. It becomes what? 7 raised to power 1 over what? 2. We move over to the next 7. Then I will use what they sign here, multiplication. I say multiply by. The next 7 I have here contains 2 square roots. This first square root covered it. This second square root covered it. And because it has two square roots, instead of going to be raised to power 1 over 2, it is going to be raised to power 1 over 4 because it contains two square roots. So we say multiply by 7 raised to power 1 over what? 4. Multiply by. We are at the next what? 7. And this 7, which is the third one, contains 3 square roots. The first one covered it, the second one covered it, and the third one covered it. So instead of saying raised to power 1 over 2 or saying raised to power 1 over what? 4, it is going to be raised to power 1 over 8. So what you have becomes what? 7 raised to power 1 over what? 8. Then we now want to apply indices before we continue with our logarithm. What do I have here? 7. What do I have here? 7. What do I have here? 7. Their bases are the same. In indices, once the bases are the same, we take one of the bases and we sum the powers. So this quantity becomes, this equals log in base 7, log in base 7. I'll pick one of what? Of the 7. So this becomes what? 7. What I have here is 1 over 2. So I have 1 over what? 2 plus. What I have here is 1 over 4. 1 over what? 4 plus. What I have here is 1 over 8. I have 1 over what? 8. That is step. The next step now becomes LCM of 2, 4, and 8 is 8. And if you take the LCM and sum this, you'll be able to have this. That this is the same thing as what? Log in base 7, log in base 7, which are what I have here. It becomes what? 7. LCM is already what? Is already what? 8. Then when you come here, you say 8 divided by 2 is 4. 4 times 1 is what? Is 4 plus. 8 divided by 4 is 2. 2 times 1 is what? 2 plus. 8 divided by 8 is 1. 1 times 1 is what? Is 1. So this thing becomes, this equals log in base 7, log in base 7 of 7. 4 plus 2 is what? 6. Plus 1 is what? 7. So we have what? 7 over 8. In logarithm, we have now come to logarithm. We are done using indices now to arrive at this. In logarithm, we are told that once the log of a number, which is this 7, is raised to a power, that we use that power to multiply the what? The logarithm. We are told that in logarithm. Once the log of a number is raised to a power, the power is this 7 over 8. We use that power to multiply the what? The logarithm, and this thing now becomes, this equals, log of base 7 is still here because this is the one I'm considering first. This is the one I'm considering. So this one should still be there. So I have log in base 7. The power is 7 over 8. I will use 7 over 8 to multiply this logarithm. So I have 7 over 8 multiplied by log of what? 7 in base what? 7. Of course, you know that log of a number to its own base is what? Is 1. So the whole of this quantity is now going to be that this equals, here is my log in base 7, log in base 7. Here is what? 7 over what? 8 multiplied by what? By 1. Because log of a number to its own base is what? Is 1. So by implication, this thing is the same as log, because 7 over 8 times 1 is 7 over 8. So I have 7 over what? 8 base 7. Equally, in logarithm, we are told that log of a number all over a number can be expressed like this. That this can be written as log of what? 7 base 7 minus log of 8 base what? 7 in logarithm. And log of a number to its own base is 1. We already established that thing earlier. So this quantity becomes log of 7 base 7 is what? Is 1 minus. This my 8 can be expressed as 2 raised to power what? 3. So I have log of 2 raised to power 3 base 7. And then you now find out that this thing is a power. So, and whenever a log of a number is raised to a power, that power is used to multiply the what? The log. And this implies, what I have here is what? 1 minus. When this 3 comes down, it becomes what? 3 log of what? 2 base 7. That is the much where you can go. Unless you are given the value of log 2 base 7. That's when you now come here and substitute in order to evaluate the final answer. So the log base 7 multiplied by log base 7 of this quantity is evaluated to be this. What have we done so far? As a way of recap, we are told to evaluate the value of log base 7 multiplied by log of square root of 7 inside the square root of 7 square root of what? 7 in base what? 7. We first of all told ourselves that this thing can be expressed this way by putting your multiplication signs this way. We now see this next thing there is to bring in the idea of indices. That whenever you talk about root 7, it is the same thing as 7 raised to power 1 over 2. Then we now come back here. This 7 you are seeing here has only one square root that is covering it. So it becomes what? 7 raised to power 1 over 2, and that is what I have here. This second 7 here has 2 square roots covering it. The first one covered it, and the second one covered it. And because 2 square roots cover it now, it's going to be what? 7 raised to power 1 over what? 4. That's what I have here. We now come over to the third one. In the third one, of course, 3 square roots are covering it. We have the first one covered it, the second one covered it, and the third one covered it. So it is going to be what? 7 raised to power 1 over 8. That's what I have here. Okay? So I'll now say, okay, fine. Bringing in the idea of what? Indices. The base here is 7, the base here is 7, the base here is 7. I pick one of the bases and sum the powers. That was how I arrived at this. Coming over here and taking LCM of 2, 4, and 8, I had this. Then by evaluation, simplification of what? Of fraction, I had 7 over what? Over 8. And I recall for us that whenever log of a number is raised to what? To a power, we use that power to multiply the what? The logarithm. But we should note that the logarithm we are talking about here is this second one and not the first one. So we still retain the first one, log in base 7. Then we now use this 7 over 8 to multiply this logarithm. That's what we did here. 7 over 8 multiplied by log of this what? 7 base of what? Of 7. Which is what we have here. We quickly recall for ourselves that log of a number to its base is 1, and that's what we have here. So we had log in base 7, which is here. This 7 over 8, which is here, multiplied by 1. Which is the same thing as log of 7 over 8 base what? 7. We quickly called for ourselves another law in indices that says that whenever we have log of a number all over another number, that it can be expressed as log of 7 base what? 7 minus log of 8 base 7. That's what we have here. And the log of a number to its own base is what? Is 1. And this 8 can be expressed as 2 raised to power what? 3. So that's what we had here. So we now say, okay, using this 3, which is the power to multiply the logarithm, we arrived at this. Don't you see the beautiful assistance of the idea or knowledge of the links between indices and logarithms of a number? The moment you have them, you can go a long way to understanding so many problems in mathematics. Please continue to like, to comment, and continue to make our classes to reach out to the rest of people. Don't forget to subscribe so that the moment we have a class, you'll be able to get it firsthand. Subscribe to our YouTube channel and turn on your notification bell. Thank you very much.